Hello students, welcome to this GS Maths and Science classes. Wish you all a very happy new year. Today we will discuss two trigonometric problems. These two problems are basically based on trigonometric identities. Now the first problem is, if tan theta plus sin theta is equals to P and tan theta minus sin theta equals to Q, prove that P square minus Q square is equals to 4 under root P into Q. And the second problem is, if x cos theta plus y sin theta equals to P and x sin theta minus y sin theta equals to Q, then prove that x square minus P square equals to Q square minus y square. Student, these two problems based on the trigonometric identities. So there are various ways of solving these two questions, but I have tried to prove this by very simple way. So the solution of the first question is solution 1. Now to solve this, to prove this P square minus Q square is equals to 4 under root P into Q, we will start from the LHS of this statement. P square minus Q square is equals to 4 under root PQ. That is LHS, which is equals to P square minus Q square. Now put the value of P. The value of P is tan theta plus sin theta equals to P. So tan theta plus sin theta whole square, and here put the value of Q, that is tan theta minus sin theta. So tan theta minus sin theta whole square. Now squaring both these expression, so tan square theta plus sin square theta plus 2 tan theta sin theta minus tan square theta plus sin square theta minus 2 tan theta and sin theta. Now tan square theta plus sin square theta plus 2 tan theta sin theta minus tan square theta minus sin square theta plus 2 tan theta into sin theta. Now this plus tan square theta minus sin square theta will cancel out, sin square theta plus sin square theta minus sin square will cancel out. Now 2 sin theta tan theta into 2 tan theta sin theta, this will add up to give 4 tan theta into sin theta, which is equals to, now you can put tan theta as sin theta upon cos theta. So sin theta upon cos theta into sin theta, which is equals to 4 sin square theta upon cos theta equals to 4. Now in place of sin square theta, we write sin to the power 4 theta, and in place of cos theta, we write cos square theta. Now to balance sin 4 theta upon cos square theta, we have to put whole things under square root, which is equals to 4 sin square theta into sin square theta upon cos square theta, breaking sin 4 theta into sin square theta into sin square theta upon cos square theta equals to 4. Now from identity sin square theta plus cos square theta equals to 1. So in place of sin square theta, we can write 1 minus cos square theta into sin square theta upon cos square theta. Now sin square theta upon cos square theta minus sin square theta into cos square theta upon cos square theta. Now this cos square theta and cos square theta will cancel out, and sin square theta upon cos square theta can be written as tan square theta and minus sin square theta, which is equals to 4 tan theta plus sin theta into tan theta minus sin theta. Here we have used the algebraic identity a square minus b square equals to a plus b and a minus b. So tan square theta minus sin square theta equals to tan theta plus sin theta, tan theta minus sin theta. Now see, tan theta plus sin theta. What is tan theta plus sin theta, which is equals to p, equals to 4p, and tan theta minus sin theta. What is tan theta minus sin theta, equals to q. So here you put 4 under root p into q. So we have reached our final result, that is p square minus q square is equals to 4 under root pq, and here 4 under root pq, which is equals to RHS. So this is what we have been asked to prove. P square minus q square is equals to 4 under root pq, and here equals to 4 under root pq, which is equals to RHS. So LHS equals to RHS has been proved. Now come to the solution of question number 2. The solution of question number 2 is rather very simple by using the trigonometric identity. So let us see how it can be proved. Now the solution of question number 2. Now if x cos theta plus y sin theta equals to p and x sin theta minus y cos theta equals to q, then prove that x square minus p square equals to q square minus y square. Now let x cos theta plus y sin theta equals to p as a equation number 1. So x cos theta plus y sin theta equals to p, put it as equation number 1, and x sin theta minus y cos theta, put it as equation number 2. Now squaring and adding both the equation. Squaring and adding 1 and 2. So x cos theta plus y sin theta whole square plus x sin theta minus y cos theta whole square. In the left we will have x cos theta plus y sin theta. So squaring, we get x cos theta plus y sin theta whole square and x sin theta minus y sin theta, x sin theta minus y sin theta whole square on the left side, and in the right side we have p and q. So when we square and add, we get p square plus q square. Now expanding these two expressions, so x square cos square theta plus y square sin square theta plus 2xy cos theta into sin theta plus x square sin square theta plus y square cos square theta minus 2xy sin theta cos theta, and on the right side we have p square plus q square. Now 2xy cos theta sin theta and 2xy sin theta cos theta both are equal and have opposite sign, so they will cancel out. Now taking x square common in x square cos square theta and x square sin square theta. So x square, taking x square as common, so we get cos square theta plus sin square theta, and y square common in y square sin square theta and y square cos square theta. So taking y square as common, we get within bracket sin square theta plus cos square theta, and in the right side we have p square plus q square. Now we know that by the trigonometric identity sin square theta plus cos square theta equals to 1. So we will have x square into 1 plus y square into 1 equals to p square q square, or x square plus y square is equals to p square into plus q square. Now transferring p square on left side and y square on right side, we get x square minus p square equals to q square minus y square. So this is what we have been asked to prove. X square minus p square is equal to q square minus y square, and we get the result here. So hence proved. This is all for today. We will meet in our next video very soon. Till then, thank you.